GPU meetups. This time we are speaking about LLMs, large language models, the technology which is transforming the world and also affecting the jobs. So we get to know more about this from our speakers. We have people from NVIDIA, we have people from the Amrit Perpetual Block and FIS. So let's see how it goes. Before we start, I have some updates for you guys. So at Innoplexus, we had participated in the biggest AI conference, which is organized by NVIDIA. It's called GTC, GPU Technology Conference. So we had like 20 plus participation in the posters, and the four they got selected. So congratulations to all the people who have participated and got selected. Second, Mr. Gaurav Tripathi, who is the brain behind this meetup, has been awarded with not one but two awards. One is BW Wisdom 40 and 40. Second is Change Ambassador by the ODP, which reports to PMO. So yeah, that's great. So for the welcome speech, I would like to welcome Mr. Gaurav Tripathi on stage. And just introduce him. For the people who don't know, of course, he's an IT software engineer with more than 18 plus years of experience. He has 45 plus patents. He has a CL in Australia, and of course, he is the brain behind these people. So please welcome Mr. Gaurav Tripathi.
Thanks, Adarsh. Welcome once again to all of you. So thank you, Adarsh, for repeating that. Oh, I've got out. You have to be the same. Is it okay? I try to be. Okay. It's distracting a bit, but yeah. So yeah, I can't technically say that I'm the brain behind the meetup. I have to say, that way it will be NVIDIA itself, because that's where the idea came. That we have been using GPUs for more than 5 years, and we realized that a lot of the people that we meet in and around, they don't even know about GPUs. They have heard, but they don't know really about the power and why they are important. Thanks to all the buzz around AI, and finally the LLMs coming on the horizon, I think there is a lot more awareness. But what I see really is, as a country, we kind of missed the bus. On the tech side, we have missed multiple buses. Okay, but AI is something which is still within our reach. Only thing is, we haven't yet realized that what the important role that computing infrastructure is playing really. We are still thinking in terms of ideas of our own, and when we talk about models, etc., but still a lot of the basics are missing, and that is where we thought, let's start getting group along, where we are able to discuss use cases, discuss about what we are executing, learn from each other. That's the meaning of a community, right? And yeah, we can of course probably say that we ourselves have a lot to share, but at the same time, we know that we have a lot to learn as well. So it's for a very selfish motive that we wanted to learn from the best of the people who are out there who are using GPUs. That's where we started with the meetup. Right? And good to see that we have been getting with each meetup, we are getting stronger. The community is growing. We are getting a lot of interesting feedback as well. And yes, of course, thanks to all of the great speakers that we are able to host with every meetup. And foremost thank always we reserve for NVIDIA. So NVIDIA team has been very supportive, and we have been getting their support almost every meetup. Their big is sitting here, and that's the ecosystem around the GPUs that we really need. And coming to today's topic, LLMs, my only bit is there that LLMs have been able to prove what people didn't believe really for a very long time. Yeah. Uh, and again, I've been one of those guys who said, yeah, it's a matter of time before it will happen. It's literally that, yeah, given enough computing infrastructure, given enough data, you can do wonders. That is how it's simple has been. But somewhere it took time. It took almost a decade to reach that space, and that's what LLM has been able to do. That when you are able to have really large volume of data, and you are able to can use the term let it loose, run it on its own error free, right? There is magic happening, and that is what we see all around. And LLMs, the experiment on humanity has just started. There is a lot that we are going to see. Yeah, there is a lot more that is going to be simply automated. There is a lot of innovation that we are going to see in the next 5 years. And that's where we see that we're at an excellent juncture of time where innovation to innovate or to come up with something, you're not even going to need a lot of learning yourself. You don't need to be an expert, yeah, because all of the tools will be available. The computing infrastructure is available, the models are available, yeah, and the tools are available. You would be able to do a lot more things a lot faster. So that's where we decided to use. In fact, the last meetup, the ask had come from members that is why not covering LLMs. So that's where today we are. The speaker lineup is great, although we didn't have much time, but I'm really happy to see a great lineup of the speakers, real experts, people who have actually implemented LLMs and been working with them. So yeah, let's get started. I'll hand it over back to others. Once again, a very warm welcome to all of you. Thank you.
Okay, so I would like to welcome our first speaker of the evening, Mr. Ashwin Rathod. Ashwin is a IT Bombay and I am Bangalore alumni. And on top of it, he has like 14 plus years of experience. He is co-CEO and founder of Amrit. He is going to talk about the real world usage of LLMs. Welcome.
Thank you so much. Thank you, JP. So today we will just browse through. I don't have much demos that I can show, but the idea is to give you, to open minds towards what are the possibilities that one can create. Okay. I've taken 3 simple examples of what we have been able to implement in ours. This spans across understanding documents using, say, RAG, and also understanding complex documents, which could be related to your healthcare. Okay, and then one of the personal favorites is creating PPTs, because I hate doing PPTs. So, sure, you can. When do you think chatbots first came to existence? What is your rough idea? In the history of computer science or AI, when do you think chatbots have been since existence? Any idea? Guesses? More than 20 years. Okay. So 2000s. Okay. Anyone else? That's way off. Hint is it's way off. Of course, many years prior to that. But what is the guess? Correct.
The concept of AI was
Correct. This is the time around 1960s. So the first chatbot was Eliza. So Eliza is a simple chatbot. It was one of the first examples of using a natural language processing for a conversation. That was early 1960s. 1950s, you're right. That's when Alan Turing, exactly.
So, but did the definition of chatbot exist then, or what was the definition of chatbot then?
This is a chatbot, right? You talk to a chatbot. This is 1960s. So it was supposed to help patients with stress or mental disorders or to converse and talk about their problems. And that is 1960s. That's early 1960s. That conversation is where it still exists, but still. So how do we go to the next one? A brief history of how we arrived at LLMs. I mean, chatbots being your favorite application, but a lot happens before. So Eliza was 1960s. It took us a long time after that, okay, to get to something very significant, and that is latent semantic analysis, an innovation by UC Berkeley. The idea was it was a very nascent, way of understanding or extracting topics. It was not for a large text, relatively very small text. That's the lesson. Then again, it took us a lot of years to get to something more, something better. LDA, which is my personal favorite, I have used latent widget allocation in one of the applications where we wanted to normalize two people. So the problem statement was across millions and millions of documents, two people with similar names, but of course they are two different people. How would you solve this problem? And latent directed allocation helped me to understand combining all of those long text, and extracting topics to map something like a cloud, which would probably best signify, person one versus person two. So again, that was by Google. Then Google, by the way, has done some amazing contributions right since the beginning. The guy who wrote the textbook on AI, I think was so Google is way ahead. I think you also saw that funny video where they keep saying AI. Sundar Pichai's funny video. They're very much into AI since their inception itself. They're obsessed about data and need any form of data. And also, I think some of the language models, which are native multimodal models of Google, will eventually overtake the other multimodal models that others are releasing, like OpenAI. Well, but that's the power of data because they have so much data. Now, next, again, it took 10 years. RNN and LSTMs. So, recurrent neural networks and LSTMs. I think most of the basic, you guys are from college. Do you know this? Yeah. So, LSTMs are long short-term memory. This actually was an age where people were innovating so much with these. They were solving the common tasks, problems related to any problem related to classification. It was a big revolution in the market. So LSTMs made a really big impact, especially for academic purposes, I would say. Also, students and data scientists all across the world were using this very frequently. One of the great applications is neural machine translation. This was again an innovation by Google. And then something truly revolutionary. This paper, attention is all you need. I think you have do you guys know about this paper? Okay. It's a very funny name for a research paper. It introduces transformers. Okay, extracting information for a long range of sequence of tokens. For simplicity, let's call it a sequence of words. Okay, this is the landmark innovation because it expanded to transformers of all kinds. When sequence-to-sequence models came into existence, it was not just applied for, say, a language processing task, but also image. It could have been used for DNAs and a lot more. So self-attention mechanism, it introduced a very beautiful, it sounds simple, but it's a very interesting concept, self-attention mechanism. And that brought an efficiency in terms of processing the speed at which it was relatively large. To train a bird also requires some compute. We used to do that in our campus a lot of times. Training bird for some very specific things. Could be medical text, could be translation related activities. Understanding specific formats of text. I typically have an experience, in my recent experience, I've worked on drug discovery and development. So medical text understanding or clinical text, research papers. So those were the challenges we are talking about, not just normal English. Please go ahead.
Can I ask, like,
Of course you can ask, and anyone can ask. Okay.
so one, I'm not from the technology background right now. I'm not from the technology background, so the question may appear stupid, but what does it mean to understand the medical text?
Wonderful question. Thank you for the question. You read a comic book, you read a story book, comprehending this information, which is very similar to your day-to-day English, the natural language you call it. Not really natural, but your day-to-day English language. That's one kind of a task. You read a newspaper, simple to understand. Now imagine reading a medical research paper. Those terms are completely new. Models which typically are state of art don't work great on medical text because it's completely different. It's a very specific domain, and that English is different from what English you read everywhere else in the world. Again, it's not just domain specific, but just the terminology, the way they write it, is very, very different. Okay, so that's why it's an interesting challenge. And that was about bird. Today, I think we have seen an explosion of GPTs, correct? Generative pre-training transforms. It's a next level of transform models. I think all of you know the work done by OpenAI, Google. Now, with the advent of transformers came a second problem. It was not just about predicting classification or understanding probability. Could you generate things? I'll talk a bit about GANs, I'll not about too much. It started with, can you generate something? Okay, generating human understandable text. Generating text which makes it feel that it's a human talking, right? She mentioned about Alan Turing. So there was a very simple test formulated by Alan Turing. If you're chatting to a human and if you're chatting to a computer, the moment when you cannot distinguish which one is which, well, that algorithm has passed what is called as a Turing test. It's a very simple test. And you don't see the people on computer, but that's as simple as that. That is the foundation of what we call AI. And intelligence is a very broader term. Probably Turing didn't imagine how to define intelligence back then, but this is how simply he put it. Okay. Today we see these innovations. It's difficult. It's very difficult to distinguish if an article has been written by a human or say generated by GPT. There is a caveat here. Of course, we can have models which can predict whether it's a generated text or a text coming from humans. there is a constant battle between all of these models. Okay. On that note, I wanted to also talk a bit on the multimodality of models. Like I said, text is like a sequence. Similarly, you can imagine an image also as a sequence. Audio can be converted into a waveform, and well, that can also be treated as an image. Video in a similar way. Okay? So multimodal models came into existence because life is not just about text, right? The data that you see every day in and out, the data that you consume, the data that you produce, has so many different kinds of modalities. So models started evolving using the same construct of transformers. The sequence to sequence models or the transformer-based models evolved to cater to all different kinds of modalities you can think of, as long as it is treated as a sequence. Okay? There are two kinds of multimodal models. One is a native multimodal, and sometimes they are dispatched. You have two different sets of models. One is good at, say, understanding images, one is good at understanding text, and they combine. GPT-4 is not a native multimodal model, but Gemini is. So that's why my conviction is, in a short term, or maybe in a reasonably not so long term, Gemini will overtake any other multimodal model. Okay? Any questions so far? Good. I was once very fascinated when NVIDIA came up with this innovation where they put up two photos, a photo of a man and a lady, and that was the introduction of ProGAN. I was so fascinated by it, we applied the same idea to generate molecules at one point of time. Could we make molecules which make sense, not random chemical structures? This is truly the era where generative AI, as such as a field, was born. Two models fighting against each other, they're like an adversary to train each other. What a beautiful concept again. So that was GANs. Of course, on the back they have variational autoencoder. What is a variational autoencoder? Any concept or any object that you can think of can be represented as a vector in a space of, say, whatever n dimensions. A variational autoencoder would be something that would find another close point to any given vector, but in a sensible way. It has to make some sense. They have to follow some theme. It cannot be just random junk. That's what autoencoder, decoder setup is. And as the name suggests, variational autoencoder with a small delta of deviation from that vector, would it be able to decode something sensible to a reference vector? That is all about VAT. And that gave birth to generative AI. A good encoder and a decoder would spot a nearest point and generate completely new. So that's generative AI basics. Okay? AlphaFold is an amazing example for how generative AI has been used for humanity. Any questions so far? Okay. Oh, this is another one. The use cases of large language models, this is a very small list. You can think of a problem these days, and you can actually apply an LLM to solve it. These are just a few curated lists of industries or sectors where this is currently being used, but I think it's being used left, right, center, anywhere and everywhere. Healthcare, for example, there is multimodality here. There are images, there are waveforms, there are texts, there are tables, okay? And we use this for diagnosis, assisting physicians to automate any kind of work that is rudimentary. The doctors typing, you have to watch them. They're so good at writing, and then when you watch them typing, they use it one finger at a time. So maybe this can help. Finance, these texts, like financial reports, or understanding the risk by looking at all the financial economics of a company. These are some of the use cases, including stock market prediction. Transformers were also used before for forecasting or predicting time series forecasting. That's what it's called. Similarly, education, I think you guys must have already got the idea that a personalized tutor is there. Transportation, of course, pedestrian detection is a classification problem. Time series data of a video, a lot of things also, but I'm just taking two as an example. This industry of retail has been using it left, right, center, starting from marketing campaigns, branding, understanding consumer behavior, tons of data, and taking very precise analytics about one person at a time. Sometimes they are that hungry. Recommendation and customer queries. I think you understand chatbots being deployed. We recently also kind of used LLMs for the use case of cybersecurity, where we were able to create a Chrome extension, understand the page, and classify if it's a phishing. Just another one, we call it SMSing, smashing, phishing version of SMS scams. And malware detection also, looking at the data from your computer, looking at the data from the patterns on a network, you could predict if it's a malware or if the malware is in action. Code generation, this is my favorite. So all the sci-fi movies where humans get extinct, there are these fancy things that happen, right? There are machines that write the code to make the machines to write the code to make. So that's my personal favorite. You can think of any kind of automation. Look at those guys. You're getting it, right? Terminator, Okay. So basically anything to do with document analysis, conversation, or wide variety of course, not just that. Let's deep dive into three of my particular use cases I want to present. We have seen search, and we have seen the problems with search. Google is still, it keeps on evolving. Search is so fundamental to Google. LLMs are a great tool when it comes to, understanding large sets of data, creating vectors, understanding the query that a user is looking for, and then using what is called as RAG, it's a retrieval augmented generation. It just not just gives you a context-bound response. It doesn't give you some random generic yarn. Now you're giving it a context, some data, some large set of documents. So it's able to give you good answers in the context of the data that you have read. So imagine if you're talking about a long pipeline of billions or trillions of web pages. Something like this on a scalable way could probably help you to make a Google of your own. So this is BioBot, which can answer queries when you have provided a long set of documents. Imagine financial reports of your company, all the financial reports of all the companies combined, or Indian penal code, the whole document related to law in a particular country. Okay, these are some of the very specific use cases when we want the chatbot to stick to the context and not go hallucinating and throwing some random idea. Okay, it's a beautiful and a simple way of doing things also. And how the way we solved it. It's okay. So the way we solved it was by retrieving some relevant documents. That's what was the use case.
Sure. So we had a challenge to fetch the relevant documents. When a query is being made, we have to bring the relevant document, just like Google gets you your search results. But not just that, but also point out to which piece of information was actually the one that contributed to this document popping up on the top. Okay? It had a really good accuracy. We tested it with GPT, and GPT is fantastic. GPT is fantastic, but my personal favorite is Llama, because I don't like systems where data is given to people who say, we will take care of data. It's like the biggest scam. So I prefer models to be in the control of the businesses. That's where I think locally deployed models like Llama. That's a simple example. What are the recommended dosage of Paxlovid? It's a question related to the drug Paxlovid. Okay, and in the chain of thought, what are the indications of say lupus? Lupus is another drug. So it goes through a lot of documents known as this clinical trial protocols. For you do a trial, you tell FDA, okay, FDA, we are doing this trial. This is the indication. These are the kind of people we need for the trial, and these are the criteria on which we will work, evaluate, blah, 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 blah. Okay? So this is coming out of the, so it brings up the document from lupus, and it also highlights which part of the document actually contributed to the answer it produced. So those two, 1 and 2, see, these are references of those pieces of information it has actually been able to do. This is a biobot, and it's a great application, especially for drug discovery companies, for contract research organizations. When they want to assimilate this data together and they have specific queries, that's where biobot is super useful for. My favorite, because I hate making PPTs, can we make PPTs? Of course, yes. There are many ways to do this. One is to, of course, tell your language models to write a piece of code, because they're not just generating your natural language, they're also generating some Turing-complete languages or the programming languages. So they're good at that. In fact, programming language is much more easier compared to your natural language. There's no ambiguity there. It's very methodical. They call it Turing complete. It's also comprehensive. You can cover anything and everything you can think using your programming language. So this one, again, we use it often in-house. I didn't use it this time, but it's a great tool where, again, context-based presentations can be made. You can also make a presentation out of general knowledge and let the language model hallucinate. That's one way. But in our case, we very frequently use context-based. Basically, RAGs is what we do. And if you see the same document generator, you give it a good context for the prompt. What exactly do you need? And it starts making some basic, at least it's like it's generating based on the themes, based on the flow. Yeah. So this is a great innovation, especially for anyone who is into managerial or MBA and all that. I think the demo of Office 365 was a level further, because since all of these applications are made by Microsoft, the underlying, the visual XYZ, all of them are written in the Visual Series, Visual Basics or whatever. They have the source code of Office. So with that in mind, and the creativity you can think of with the chat GPT, you can actually design templates. One
one good demo that they presented was preparing a template, a PPT for the daughter's birthday or baby shower or something. So, and then a beautiful PPT comes out with nice, infographics, design, colors, fonts, etc., all taken care of. So yeah, this is the very basic part of it. This was before. This is a long time back, before Office release. This one is a very interesting use case, picking up a lot of traction. Understanding electronic health records and to help diagnose a particular indication, a disease, a condition. And take it to the next level. The question is, could it recommend the next steps? Could we have a way in which we could ask ChatGPT, what should I do now? And I think it's good at that as well. So, Medscape was an app prototype we wanted to test. We wanted to test the market to gauge the product market fit. And this does exactly the same. It lets you take a photo of your any pathological report or any report, and then kind of arranges it. First of all, it extracts very basic critical information. It helps you to visualize this on a timeline, as in maybe on a Friday last time the blood pressure was low, but on Saturday it was high. So it helps you monitor that. And a lot more. It tells you what does it mean for the user to have this condition. What does that report actually mean for the user? Are there any abnormalities in the report? Usually people go to a doctor. The doctor says, okay, go to the lab and get this test. And then they come back to the doctor again, right? So maybe that second round is not needed unless, you can check if there is no abnormality in it. Okay? Or combined reports, multiple reports combined, in fact, combined over time, can also be useful diagnosis. Like doctors do that, right? They ask you for your file. Okay, file de do hum dekh lenge, and then they start checking the reports quickly. So that's the idea. And the next is a demo. You can just click on this one. It just yeah.
Two login options using OTP and social login.
Whatever.
Also, you can see the consent page, which helps us to get your app ready for easy processing and accessibility. Add this user create a profile by providing their name, age, and gender. The button will show multiple options to upload the document.
It doesn't, however, understand human written text so well. So if it's a doctor's prescription, I wonder if there will be ever a model that will probably decrypt this doctor's or physician's handwritings. It doesn't do that yet, but maybe soon, I don't know. So it's trying to go through the document, understand the layout of where the text is written, how it's written. It also tells what are the abnormalities. Everything that you see over here is being generated by an LLM. There are reference links to what it has generated, of course. It's not utter rubbish. And yeah, it's a great way to track, store, share, and maybe come back and also understand if, things are going right or wrong. Okay? So these are the three demonstrations I wanted to show you today. Do you have any questions? Anything? Yes.
Thank you so much for the demo. We just wanted to have a better understanding of what's happening technically inside the demo, like what LLMs being used, and what type of algorithm are used, something like that, more technical information if possible.
Oh, I'm out of frame. Okay. So, few things here. First, of course, we tried multiple experiments, and we felt that GPT currently is good enough to tackle multimodal data. But of course, you can use other multimodal models like layout. There are series of layout LM. There is some amazing work being done by Alibaba in the same space. So on a two-dimensional image, okay, information is, you can say, structured, but not so easy to extract, okay? We use the layout capabilities, and then comes the point of structuring this text, structuring the key findings, their values, units, and the range, because units change. Some write centiliters, some write milliliters, some use milligrams, and the exponentials are different, correct? Sometimes it's just 0.01, or people write 10, and then 10 to the power minus 3, in all different kinds of formats. So the model, the chat GPT, is clever enough to understand all of these complexities. We structure them, standardize all of this in one particular way. Units, like I said, we also normalize them because, of course, two different labs write two different ways. One says white blood count, white blood cell count, other says WBC. That is a slight example, but both of them are same, right? And after that comes a long list of thousands and thousands of texts, the tests, pathological tests, which are again backed by medical research. So there are guidelines for tests, how they should be conducted, what are the standards of the instruments that you use to conduct such tests, how you report them, what are the deviations that you should mention, what's the standard deviation to the result that has been mentioned, so on and so forth. And those are the references that you see when it's okay. I think you guys can hear. So those are the references that pop up also as a supporting document if the person wants to read further. Okay? A lot of times, depending on the machine that is being used to do a test, the reference range could change. Okay? So we have to take care of that. Sometimes, depending on which country you come from or your genetic build-up, the range could be different. Depending on the gender, hemoglobin range are different. Age also, and so on and so forth. So all of this has been taken through, there are handbooks and journals about pathology. Okay? And then, of course, RAG comes into it. The significance, the next step, recommendations, etc. Some from ChatGPT, but also from the corpus of all this data that we have in the back end. That's what we do. Does this answer you? Yeah. Okay. You're audible.
So when I say about GPT,
Yeah.
we are talking about ChatGPT, but ultimately it is going to be a generative pre-training.
Yeah.
Somebody is entering something.
Yeah.
You said the particular software is giving 90% of the accuracy.
Correct.
Every action has an equal and opposite reaction.
Mhm.
So the data which is entered by the people, there is always a negative thought about that. So probably if I'm going to say somebody is doing something and AI will be catching the right thing, but there is a possibility that it can catch the wrong also. So how you are getting that particular thing done?
Very good question. Again, the capabilities of AI are still not at the point where it beats a human. I see a lot of claims in the news that this is better than the human, but intelligence, like I said, is complex. Also, there is a bias. So these are very subjective questions or answers that it generates, correct? On a fact-based thing, we can still be close to, what we can define as accuracy. But on a subjective basis, it is difficult. There are different kinds of tests that have been invented for it. There is MMLU, there is for factual answering, there is a chain of thought, all different kinds of ways in which you evaluate models. And of course, even in the human evaluation, I would say, there are biases, correct? So there is a thing called as Cohen's alpha. Like if I give you 100, say items to validate, and I validate it myself, what is the similarity? Assume that both of us are at the same level of intelligence, expertise, etc. There are still chances that we will differ, right? And these are the things. Hence, a lot of people, medical experts, validate this thing, and we take up a sample of a few thousands here, so that there's a reasonable, what we call a confidence in whatever we report. So that's also, there are different ways to do this, but yeah, these are some very simple ones.
As you said, getting a one occurrence will add it up. Because suppose if I am putting across something,
Yeah.
hundreds of followers are going to follow me.
Right.
So what AI is going to do, a particular thing which has been defined.
Yeah.
One person is saying no and 99% are saying yes.
Yeah.
The 99%, one person might be saying yes, the 98% who are following him might be saying the same thing.
Could be.
The one who is going to say might be right, but as 99 are saying, the AI might compete with the 99. So that is why how you are catching this up.
Wonderful. Lucky for us, for this application, we don't go by opinions. What we go by are some factual, vetted, medical, documents. So at least in pathology, you have various handbooks. There are defined procedures. There are defined metrics how to do it. So lucky for us, I guess. So this is not an opinion that we give. We actually give it based on some medical research. Also the recommendations following that.
Yes.
So, videos.
I think there are a lot of questions, but I will take it offline with them. Okay.
Sorry, we are
Thank you so
running
much.
short on time, so we have to wrap up.
Thank you so much.
Others, before you introduce the next speaker, I will just add something.
So, just to add, yeah, ठीक है, फिर I just, I'll get blind. Oh, okay, so thanks, Ashwin. I just wanted to make a small announcement that this guy standing here, Ashwin, just a couple of days back, his team won a hackathon, which was by Rajasthan Police. Yeah, and the hackathon, they had like 1,200 people participating from all over the country, and his team was there for a problem statement was around crypto. Yeah, and in the overall hackathon as well. So crypto one, they won it. They were first, and overall hackathon, they won the silver medal. So great going, Ashwin. He received the award from the hands of Honorable Governor himself. So that's great.
Thank you so much.
Yeah, others, over to you.
Thanks, Ashwin. So next I would like to call upon my friend Mr. Megh from India. Of course, I don't have to set the context for India, as in if it was not the technology provided by India and the mature libraries which can learn about the hardware, then I think we would not be standing here discussing about LLMs. So I would request Mr. Meeh Makwana from India to share his plus knowledge with us. So Megh, over to you. Hello. Everyone can hear me here. Hello everyone. Thank you so much for coming, and thank you so much to the Innoplexus team who has been, hosting these meetups. And I think it's a great initiative because, going forward, one thing is becoming very obvious that this technology is literally going to change how we use our applications on a daily basis, and it will literally change all aspects of our life. And again, because at the end of the day, one thing that people really don't see is, what is it that you really need to run these things in production. And what I'm going to do today is I'm going to try giving a little bit glimpse of the underlying technology stack. And one important aspect is, people are building this, and you will see great demos for English. What about Indic languages? It's like a very open question that we all have, and there's some really good work that a lot of people are trying to do, but I'm trying to share what is it that we are trying to do. So with that, let me just quickly show you a quick demo of a voice bot. So basically, what this voice bot does is you can ask your query in Hindi in your voice, and then based on the query that you have asked, again, this is going to be a very domain-specific voice bot. Okay, it's not something that will answer all kind of questions. It's very specialized in terms of what it does. So if you ask about queries around any government schemes, which is there on mygovschemes.com, it will be able to get those scheme-related information for you and give you the answer in natural speech back. And if you see, one of the key things that we actually verify here is that it needs to work in real time, because if it doesn't work in real time, people are not going to use your application. If you see a video of 5 seconds, 10 seconds, I'm sure the entire user experience is not going to be great. So how do you make sure that these voice bots, which are again powered by large language models, information retrieval or RAG systems, along with ASR text to speech, how do they work in near real time? So
सरकार की कुछ और तकनीकी शिक्षा विभाग द्वारा एक विरोध योजना मिजोरम रिसर्च फेलोशिप क्या है? मिजोरम रिसर्च फेलोशिप पर सरकार की कुछ और तकनीकी शिक्षा विभाग द्वारा एक फेलोशिप योजना है मिजोरम का। इस योजना का उद्देश्य उन अनुसंधान कार्यकर्ताओं और शिक्षकों को वित्तीय सहायता प्रदान करना है जिनकी आयु 45 वर्ष से कम है, जिन्होंने अनुसंधान के लिए अपनी प्रतिष्ठा स्थापित की है या डॉक्टरेट की डिग्री प्राप्त की है या अपने श्रेय के लिए अनुसंधान कार्य प्रकाशित किया है और स्वतंत्र अनुसंधान कार्य के साक्ष्य दिखाए। आवेदक को पिछले विश्वविद्यालय की परीक्षा में औसतन कम से कम 50 अंक प्राप्त करने चाहिए। यह योजना मिजोरम के वास्तविक स्थायी निवासियों के लिए खुली है। प्रधानमंत्री आदर्श ग्रामीण योजना एक लाइन में बताएं। प्रधानमंत्री आदर्श ग्रामीण योजना (PMIST) एक ऐसी योजना है जिसका उद्देश्य प्रासंगिक केंद्र और राज्य सरकार की योजनाओं और अंतराल भरने वाली नीतियों के अभिसरण कार्यान्वयन के माध्यम से अनुसूचित जाति बहुल गांवों का एकीकृत विकास करना है। प्रधानमंत्री उज्ज्वला योजना क्या है? प्रधानमंत्री उज्ज्वला योजना (PMI) पेट्रोलियम और प्राकृतिक गैस मंत्रालय की एक प्रमुख योजना है जिसे मई 2016 में शुरू किया गया था, जिसका उद्देश्य ग्रामीण और वंचित परिवारों को LPG जैसे स्वच्छ खाना पकाने के ईंधन उपलब्ध कराना है, जो अन्यथा पारंपरिक खाना पकाने के ईंधन जैसे जलाओ लकड़ी, कोयला, गोबर के आदि का उपयोग कर रहे हैं। इसके फायदे क्या हैं? प्रधानमंत्री उज्ज्वला योजना (PMI) के लाभ में शामिल हैं बेहतर स्वास्थ्य, पारंपरिक खाना पकाने के ईंधन को स्वच्छ खाना पकाने की गैस से बदलकर इस योजना का उद्देश्य श्वसन रोगों और फेफड़ों के संक्रमण जैसे कीटों वायु प्रदूषण के कारण होने वाली स्वास्थ्य समस्याओं को कम करना है। तो पर्यावरण संरक्षण, स्वच्छ खाना पकाने की गैस का उपयोग, जलाओ, लकड़ी और गोबर के जैसे पारंपरिक ईंधनों पर निर्भरता को कम करने में मदद करता है, जो वनों की कटाई और वायु प्रदूषण में योगदान करते हैं। महिलाओं का सशक्तिकरण, यह योजना पारंपरिक ईंधन एकत्र करने में महिलाओं द्वारा खर्च किए जाने वाले समय और प्रयास को कम करके लैंगिक समानता को बढ़ावा देगी, जिससे उन्हें अन्य उत्पादक गतिविधियों में शामिल होने की अनुमति मिलती है। 4. ऊर्जा सुरक्षा, स्वच्छ रसोई गैस का बढ़ता उपयोग आयातित जीवाश्म ईंधन पर निर्भरता को कम करके देश की ऊर्जा सुरक्षा में योगदान देता है। 5. आर्थिक लाभ, यह योजना पात्र लाभार्थियों को एलपीजी कनेक्शन और यूनिट की खरीद के लिए वित्तीय सहायता प्रदान करती है, जो उनके जीवन स्तर और जीवन की समग्र गुणवत्ता में सुधार करने में मदद कर सकती है।
Now again, if I tell you that this entire demo was built using open source tech, literally we have not used any APIs, we have not used any proprietary software, purely based on open source. So the goal here is that a lot of everything from ASR, text to speech, what we as a company really believe is that we need to democratize these models and make them open source. So everything right from the ASR, text to speech, a lot of all these models are open source, and I'll share details later about it. Okay, so what did we see? Okay, because that seemed like quite straightforward demo, but if you actually look at it from using different deep learning models, you'll see that there are multiple of them that are working. It's not like one model that is trying to do everything. So in the initial phase, you have something called a speech to text or ASR, which converts your raw speech into the corresponding text part. Again, it's an Hindi ASR model. Then it basically goes to a backend engine. Now here, if you actually see, the way we have built it is in two ways. The first thing that was even mentioned earlier is that we use something called as IR, which is called as information retrieval. The reason why information retrieval is important is because you want to get knowledge from live sources. You want to make sure that whatever the LLM is generating is being generated from a known source. Because one of the key questions that a lot of people have is, what if it hallucinates and gives answer which does not have any factual basis? And that is why IR plays an important role, because you know from where this information has been retrieved from. Post that, you use something called as a reranker. So think about it like this: when you use Google search and you do search, you get like multiple pages. And then you want to shortlist those pages, right? You're not going to look at all those pages. You might do some kind of a re-ranking or sorting on top of it. And then based on that top 3 sorting, you're going to take the context, whatever has been retrieved, and set it as a prior context to the LLM model, saying that, hey, this is the contextual information that I've retrieved and filtered. Please go ahead and use this information and generate the answer based on the query that the user has asked for. Then you have an LLM model that essentially is then going to do the generation step. I'm going to make this talk slightly technical after this, in a sense that I'm going to give you a little more low-level detail of how these things work, because in terms of building applications, we don't really need to do that. We all can programmatically build applications, but what is also important to understand some more details of how these work on a fundamental level. And then once the answer is generated, we stream that answer, because it's not waiting for the whole answer to be generated. It's generating some text, and that generated text is then being pushed out to a text-to-speech system that converts that text into raw audio. Now, if you wait for the entire generation step to finish, that means for the entire answer to be completed by the LLM and then send it to a TDS, you're going to see a lot of delay. But in the demo, you could see that it was less than a second, which is what people would generally expect. People are not going to wait for 5 seconds for the assistant to give a response back in speech. So yeah, that's the overall architecture. Now, because this talk is more about LLM, I'm not going to touch the other components, but trust me, each of the other components are also have their own set of challenges. But let's talk about LLM. Now, if you look at large language models, there are a lot of different parts of building a LLM/RAG application. Okay, let's look at it from the very start. So as usual, there's always a data preparation phase, there is a training and customization phase, and there is a deployment phase. I'm sure everybody already knows about data preparation, but on a very simplistic level, the way these models are trained, think of it as a simple text file. And inside the text file, you just have a lot of text, like literally like a couple of terabytes of text. And if I had to convert and count the number of words that are there in the text, you can assume that a lot of these models like Llama and others, they are trained on some trillion words or some words, as we would like to call it. So you curate those trillion tokens, and then you basically do something called as pre-training. Okay, that's the first phase of building the LLM. That means you take these GPT-like models because they're generative in nature, unlike the other architectures like Word, which are more extractive in nature. You take these GPT-based models and you do something called as pre-training. In a very simplistic fashion, the way to visualize this in a very simplistic fashion is think about a system that is given some text, it is just predicting the next word. It is as simple as that. It's not that complicated. It's just trying to predict the next word, and it is trying to reduce the entropy of the word that has to be predicted. So think of it like this, that when you start the training, like when it looks at the first set of text, first set of text words, it's going to output what? It's going to output gibberish because it has not learned the internal semantic information of the text files. But as you keep training it on more and more tokens, going from say 1,000 tokens to trillion tokens, inherently these models are learning some kind of an internal compression of the language. Okay, so think of it like this: you have taken a lot of data from the internet, and now you are taking these neural networks, which are very small in nature compared to the amount of data that is available. So let's assume on the internet, again hypothetically, there is 10 trillion words available on the internet. The model that you have is only few billions of parameters. Essentially, what it's doing fundamentally is that it's taking those trillion tokens and compressing that knowledge within those trillion words inside few billion parametric space. And that parametric space is nothing but your model. Okay. That on a very high level is what it's sort of trying to do. It's trying to compress this knowledge which is available on the internet. And it's just doing next word prediction. Now, if you actually look at it, these next word prediction models have a lot of issues. And I think a lot of people already mentioned about it. Biases, hallucinations. It's not really, the answers are not very friendly. Are they even factually correct? There are a lot of problems, right? And that is where you go to the next phase of training called as model alignment. In very simplistic words, the model alignment part of the training tries to take this next word prediction model and tries to convert it into a helpful assistant who is reliable. So how do we do that in a very simplistic? If somebody has to ask a question, hey Megh, how do I go from next word prediction to an assistant who is helpful? Okay, how will my training data look like? So think of it like this. You have these two kind of system text, one is user and the assistant. User is nothing but a question that the main user is asking, and assistant is nothing but what the GPT model has to generate. So the user might have a question like, hey, can you tell me how can I create an atom bomb? And maybe in the assistant section, you will have an answer saying that, hey, this kind of question doesn't seem like a good question to answer, and I'm going to refuse to answer it because it might have some negative effect. So you create multiple such samples of having user and assistant, and then you sort of are trying to now make that next word prediction model, and you're trying to tell it that, hey, what kind of queries should you not answer? And you'll also provide a lot of user queries and answers which are factually correct. Now, when you create such a high quality data of such user assistant prompts, and when you train this model again, what ends up happening is that you start seeing that if you ask a question that might have some hateful answer, it is going to say that, hey, I cannot answer this question. And that is what alignment means. Obviously, it's more complicated than that. That means you also have some more phases, but in a very simplistic fashion, that is what we are trying to do. Okay, in the alignment phase. Then comes the IR part. That means information retrieval. That means given a query,
get me the top 10 relevant passages from the knowledge base that I have, and then I want to use that to answer the question that my user has asked. Okay. And then you have inference, and then you have another thing called as guardrails. Guardrails is like an external software tooling that we have built to avoid the LLMs to generate hateful content. Again, that itself is a topic in itself, so I'm not going to go that in detail. But we have software application for each part of the process. So when people think about NVIDIA, people think that hey, we build chips. We build that. We build chips. We do build pretty decent chips. But we actually build a lot of software that is required by enterprises and end users to build their end-to-end application. Can you go to the next slide, please? Okay, just to give you a quick glance of what other softwares that I'm going to talk about for each part of this. So for the data preparation stage, we have a platform called as Nemo Curator. I'll not get into a lot of details, but yeah, so we have a tool called as Nemo Curator. For training, we have a toolkit called as Megatron LM. For alignment, we have something called as Nemo Aligner. For doing deployment, we have something called as TensorRT LLM, which is nothing but a compiler technology, which I'll talk in more detail to optimize these models. And then we have something called as Triton, which takes that optimized compiled graph of a GPT-like model and then converts that into a serving endpoint. Because I'm sure all of you who have been building software, you are used to hitting API endpoints, right? So Triton will take that model and serve it as an API endpoint in very simplistic fashion. Then you have retrieval for Nemo Retriever for doing retrieval, and then you have Nemo Guardrails for blocking hateful answers coming out of LLM. Okay, quickly, like I said, how are LLMs trained? You take a lot of data from the internet, about 10, 15 terabytes, even more than that. That's what people are doing. You collect all that raw data, put it in like a simple text file, and then you take a large-scale supercomputing cluster with GPUs, and then you train them for a couple of days. Okay. So in case of Llama 70B, Meta took about 6,800 GPUs, trained it for 12 days, and then you have a model, which is a pre-trained model. Obviously, after this, you're going to do alignment on top of this. Can we go to the next slide? Okay, now how does LLM inference works fundamentally? Now again, this is an important aspect to know. Although we don't need to know all nitty-gritty details, but in simplistic fashion, how does inference work? That means how does these models generate things? So what you're doing is the first thing that you do is you take some prompt. Okay, the prompt might say something like, "Hey, you are a helpful assistant, and please answer to the point." And the answer, whatever you are giving, needs to be factually correct and has to be less hateful. This might be something like a system prompt that you might give. And it's a fixed prompt that you'll always give before any query. So you have a fixed prompt, and once you have this fixed prompt, you might have, say, about 32 queries coming from 32 users. So what do? So you basically batch all these queries that are coming, append the system prompt on top of these queries, create a batch out of it, and then you take this batch, which is nothing but a large matrix, okay, like a batch of matrix, and then you basically send it through the LLM for doing something called as pre-fill stage or the context phase. You can call it a context phase, or you can also call it as a pre-fill stage. Once the pre-fill stage is done, you then then the next step that you do is called as a generation phase. That is where the LLM is going to start generating one token after the other. Okay, so these are two phases. You have queries from multiple users, you batch those queries from different users, append the system prompt on it, take that entire matrix of different queries that you have, send it to the LLM. It now has the context of all the queries, and now it's going to generate the answers for all these different queries that have come in. Okay, which is the generation phase. And if you look at the generation phase, it's pretty simple. You send the input, one answer is generated, you send that back. Now it's going to look at the entire thing, generate one more token on board, send it back, generate one more token, send it back. That is as simplistically how these systems work. I'll show you a more easy to digest diagram after this. Can you go to the next one? Okay, let's just go to the next one. Okay, So, say for example, you ask a question saying that, hey, write a story about NVIDIA. Okay, so you send that to the LLM. Now, the LLM has a simple thing. It will look for something called as an EOS token, which is end of string token. Okay, an end of string token will come once the LLM has generated the whole answer. So basically, it's a very simple loop. Keep generating the next word till the time you find an end of string token. If you go to the so the first thing you send the prompt, the context phase or the prefill stage is done. You have an LLM state now. Now you're going to generate the next word. You go to the next slide. Yeah. So the first word that will be generated is once. Next. Yeah. Then upon. Time in. Yeah. And then you'll keep doing that. So basically, till the time. No. Yeah. So you'll keep generating each of these words one by one, or rather, you can also think of a part of the word which is also called as a subword. You keep generating it till the time you don't find an EOS token. So basically, after this, after graphic processing, you're gonna get something like an EOS token, after which the LLM will stop generating the next one. So this is on a very high level how these systems work.
How is it decided when to give or who gives the EOS?
The model knows when to give the EOS token. Can you go to the next slide?
So then it is not just thinking of the next word because then it knows the full answer on its own and saying that does it make sense. I mean,
Kind of, yes. And that is what the point is, right? You are compressing the knowledge that you had on the internet and you have compressed that now knowledge into these small billion parameters. So you had terabytes of data, you compress that inside a billion parameterized model, which is more efficient in terms of giving the answer. But yes, what you're saying is right. It somehow knows when to stop because it has probably seen those things before. And that is why if you see, for a very generic queries that you might have, it will always give you very great answers. But if you ask something tricky, which is say about your organization, it might not know about it. And that's where you use RAG because then you can use RAG to retrieve the knowledge that you have in your enterprise or in your own knowledge base and feed that to the LLM because the LLM is not trained on that. That is where RAG is helpful. Okay, let's go to the next part. Now let's talk about another interesting topic.
Take the generate LLM model and you give a organization specific information to it and retrain it again.
You can do that absolutely, or you can build a RAG system. So you can. So if you do fine tuning directly with your own organizational data, then you don't need RAG. But then the thing is that now when you're generating the answer, you'll have to do some kind of validation to make sure that all the answers that it has learned from your internal data, all the answers are coming out to be correct. So there will be like a validation check. In terms of RAG, the best part is you can go back and see from where did I get the answer. So that's a quick difference. People do fine tuning absolutely, but then again, there are certain tricky things that you have to do like validation before you put it in production. Now, why do it for Indian languages? It's like a very common question people have, and even government is saying, hey, why should people do it in English? And the answer is very simple, and I'll tell you that answer in a bit. But obviously, one thing that we know is that India, there's a lot of diversity, and there's a lot of what I personally feel is that we need to use this tech to help people who are not from very privileged background and help those people first. Obviously, enterprises and others will obviously benefit from this, but my personal take is we need to build it for those kind of people who need this tech to be there for them and help them get uplifted. Very good example is, like I showed you, right? Government schemes. A lot of farmers don't really know what kind of government schemes are actually there. Now imagine they can just simply speak in their own mother tongue, whatever query they have, and they can get scheme level information, which before this, they had to go to a website, read it in English, search through different URLs. Trust me, people don't want to do that today. And a lot of people don't have time to even do it. So can these systems actually make their life easier? Go to the next one. Yeah. I know the text is not very properly visible, but I just try giving the gist of why build foundational language models. People say that, hey, I have Llama and why do I need to build it from scratch with the language? Everybody has this question, why? Why should we do it? The answer is very simple. The answer to that is you need to look at something called as the tokenizer or the vocabulary of the model. So think of it like this. All these LLMs, because they are next word predictors, they have something called as a vocabulary. Now, if you see, if I want to generate Hindi words from GPT-4, the number of
times I need to run that, generation step is almost like about 80. I think it's around 80 or something. So this was the English sentence. If I want to generate this English sentence, I need 16 generation steps. That is why I talked about generation here. I need 16 generation steps. If I'm doing it for Hindi, you see that goes to 80. What does that mean? That means I need to pay more money to generate the same answer in Hindi. Does that make any kind of sense? No, it does not. It's computationally inefficient and you're paying more dollars because the model does not have the vocabulary of Hindi in terms of subword. It has it in characters. I'll show you that next example as well. And this was the case with Mr. Alan Lama also. And I'll show you exactly when I open that vocabulary file, how does it look like. And that is why it doesn't make sense and we need to build our own Indic models. Next one. So we have open source some of these models called as Innoplexus models. I know it's not very visible, but on the topmost side, we basically have the vocabulary of the Llama model for Hindi. And you see that it is only about 38 alphabets or characters, right? That means it will generate, say for example, if I want to generate Megh, which is Ma, A, and Gh, which are like 3 characters, it needs to do 3 generation steps. If I train a model which has been pre-trained on Hindi, it probably needs only like 1 token generation. Okay, just as an example. So here you can see that the vocabulary of some of our open source models is much larger compared to these Llama models. And obviously we are also building a foundational LLM model with some of our partners, and probably I'll talk about that slightly later in the future. Can you go to the next slide? Yeah, okay, I'm just going to do a very quick rundown because of the constraint on how much time. Okay, just some quick benchmarks and then I'll try ending it. If you have more questions, just ask me after this presentation. So what am I talking about next, right? Because I talked about all those problems and other things. The next important thing is efficiency in terms of training and deployment of LLM models. How do we make these LLMs more efficient in terms of deployment? An answer to that question is use toward precision. Typically, what happens is that when you train these models, when we started training any AI model or deep learning models, we started with floating point 32, okay, which is like a data type within your computer memory system. That requires about 16 bytes of memory, 32 bits of memory. Now, what we do is that now what we have come up with specialized hardware architectures and specialized software where you can train it in much lower precision like FP8, which is like 4 times less than that of FP32. Okay, and the kind of performance, you can see that these are like different loss curves that I've plotted, and you can see that the loss are very identical for FP16 as well as FP8. But if you go to the next slide, you will see that the kind of throughput that I'm getting is quite a bit. Okay, so if you see from our previous architecture, which was A100, just a GPU architecture, we were approximately getting about 33,000 tokens per second. And by using the FP8 optimization along with the newer architecture, we have moved it to about 90,000 tokens per second. Okay, this is on 8 GPUs. So it's about like 3x more training performance that we're getting. That's the kind of innovation that we're doing from the last architecture to the Now I talk quickly about inference as well. Now we have a stack, like I told you, called as TensorRT LLM, which is like a compiler technology specifically for optimizing neural networks. And the reason why you should use it is because a lot of great people who are deploying LLMs are using it. Okay, and it provides you the best performance compared to any other compiler tech that is out there. Okay, this is important because I'm sure at the end of the day, everybody asks me the same question: Megh, how do we reduce the cost of deploying LLMs? And so the answer to that question is use quantization. So we have basically the TensorRT LLM supports all these open source LLM models, and we support different kind of quantization all the way till int4 with activation of A16. So this way, what you're basically doing is you're making the models much smaller, plus the computational requirement and the throughput that you'll get will be much higher. So we have implemented a lot of these state-of-the-art quantization technique within this compiler tool that we do. Very quickly, just how to do it. Again, all of this is on GitHub, so you don't have to worry. I'll share the links at the end of the day. You can go ahead and check it out. Okay, how do we do this? Okay, if I'm going to use TensorRT LLM, how easy is it to doing this kind of optimization, right? Do I need to write 1,000 lines of code? Answer is no. What you do is go to the GitHub repository. There's this first stage where you take the model from Hugging Face or other open source repo from wherever that model is hosted. You pull that model down. Once you've pulled it, then we have something called as a build phase. Now this build phase is going to take that model from Hugging Face, right, like a Llama model, can be a Falcon model, can be any other open source model, and it's going to apply a lot of optimizations on top of it. And these are like different flags. I'm not getting into a lot of details of it, but you can use all these flags to create an optimized version of this model, which is TensorRT combined. So approximately, see for example, if a Llama 7B takes 14 GB of memory, if you optimize it to FP8, you can go all the way till about 7 GB itself. That means half reduction of the model size. Yeah, and then you have a simple script called as run.py. Everything is on GitHub, and you can run this to start generating using the engine that was created using build.py. Okay, so 2 stages. Download the model, run build.py, compile this engine for TensorRT LLM, which is in the build phase. Then you can run this run.py and you can start running it. Yeah. Now, next question, why is it important? How much improvement do you see? These are some raw numbers comparing the software. Now, if you actually see on the same GPU architecture, which is H100, we saw twice the improvement in the performance just by using the latest version of the software. So, a lot of innovation actually comes on the software side than the hardware. In a sense that, say for example, today you're getting some X performance, tomorrow we are going to make it better so that you get 1.5x to 2x more improvement. So compared to the last generation, which was A100, compared to an H100, which is the latest generation, with this tool, it will give you 8x more performance, which is 8x more throughput. Similarly, for Llama 2, you can see that the improvement is about 4.6x. Again, the key message that I'm trying to give is that just don't look at NVIDIA as a chip company. Look at all the software tooling that it is building on top of the hardware and start using that software. That is where you're going to actually save the most cost. A lot of people come to me saying that, hey, GPUs are very costly. I should probably try some other alternative. I tell them, hey, have you tried our software? And they'll say, no, we have not. And I'm like, you need to go back, use the software, and then come and tell me whether it's really expensive or not. Okay. I think that was the last slide that I had. Yeah, some more throughput numbers just for those people who are deploying these kind of things. For Llama 7B on an H100 with 768 batch size, you can generate about 20,000 tokens per second. Okay, just some numbers on a single GPU. Yeah, obviously other numbers are there, but just in interest of time, I'm going to stop here and see if there are 1 or 2 questions. Yeah.
So the question was, what is the vector database that you have used? So
you must have heard about Fios and Windows, right? Now, you actually look at Fios and Windows, or let's talk about Windows. At the bottom layer, it uses something called as Raft, which runs on GPUs. So what we have done is, we have built those low-level primitives to run the vector indexing and search on GPUs using Raft. Now, something like a Milvus, the Milvus company have basically now integrated Raft within their platform. So the answer to your question is we are using the Milvus vector database, which is running on top of GPUs using the Raft algorithms which are there.
Thank you for a very nice presentation. But I'd like to give a little context. So, थोड़ा हिंदी में बोलता हूँ क्योंकि हमारे customers वैसे हैं. तो हमने AI assistants लाइव किए, तो roughly 900 users को use कर रहे हैं. तो जब तक और मुझे इन्वेस्टर बहुत बार पूछते हैं कि ऊपर AI ने सब कुछ कर दिया कि आप क्या करोगे? Everything is working fine right now in your environment. When you ask the questions, it's giving very perfectly good answers. You're asking what cars and what's that, giving answers. जैसे ही मैं लाइव में इसको 900 लोगों तो क्वेश्चन आते हैं कि भाई मेरी गाड़ी खरीदने को औकात नहीं, ठीक है? तो ये क्वेश्चन I mean this is the real world scenario how people are going to use it. and then everything goes on top because we sentiment analysis. अभी क्वेश्चन आता है कि ये पॉजिटिव सेंटीमेंट था कि नेगेटिव था, लाइक वाज इट सैड सेंटीमेंट और वाज इट कि भाई मुझे कुछ बताइए उसको everything apart from that goes on notes, like even the testing तो इसको ज़्यादा इंटरेस्ट नहीं देता. So the question actually is that like you help to the partners you help train them. So can we do that for Indian specific conditions? Can we have some programs?
So we do have certain programs called as Inception, which is like our startup program where people who want to be part of the Inception program can be part of it, and there are obviously there are certain engineers who are assigned to that program who can essentially help and provide best practice. But yeah, that's how we do it. Otherwise, there's always community forums. You can put your queries there, and somebody from the engineering or other research outfit will kind of.
The benchmarks that you have established for not for but for the accuracy and the regarding of
No, so with FP8 there is no.
Regarding and benchmarks for checking the accuracy of the system.
Actually, the thing is that is quite tricky because it depends from benchmark to benchmark. We don't have it for railguards, but I mean, we will be doing some more study and we'll share it on our GitHub repository. But currently, we don't have it.
Yeah, so I have a question on the innovators. So they big hurdle at the basic access to GPUs. They are quite expensive. So I can use any scale or any other platforms like that. But does NVIDIA itself provide any such platform where we can use some cheap GPUs for some initial part of the innovation?
So we have great partners across. So the only message, I mean, the way I would probably answer this is look for Indian cloud service providers. They're going to provide you GPUs at a very good cost, which will not feel as expensive as what you'll find outside. And I mean, if you are just following the news, you must have heard about Toyota as a company is setting up a large-scale GPU infrastructure with 60,000 H100s. If you look at their website, they are literally selling it at the cheapest, even cheaper than Lambda Labs. So for your answer, I would suggest look at the local CSPs. They are growing big in India. A lot of GPU infrastructure. Toyota.
We are from Toyota. We will help you. You can catch up.
Any other questions? Yes.
Thank you so much, Megh. Please give him a big round of applause. This was very informative. Okay.
I'll just add actually. So Megh mentioned about the Inception partner program. I just wanted to share that's where we at Innoplexus started. Yeah. We became an Inception partner from Germany because at that time even the partnership program in India wasn't live when we wanted to become partners. We became partner in Germany and we started and we really got great support. Although I'll say even in terms of the software which Megh is talking about, at that time it was hardly a fraction of it, but even that helped us. Now I'll say it's the amount of work which has been done in terms of the software side, the kind of library, the SDK, everything. It's a whole big ocean. So trust me, you will find a lot of things in there, and especially with the community. And again, as I said earlier, this is the reason why we are getting a community across because a lot of people are trying something, and you can always learn from others who have already tried out something. Yeah. Thanks. Others.
Okay, give us just 2 minutes.
Can I have 5 minutes? I just wanted to propose a coordinate so that people can reach out as a big and also about the platform. So I just I just wanted to do the following.
Guys, I am Vishal Patel from Toyota as Megh mentioned, we have started our Shakti Cloud, which is called by NVIDIA, and H100. Unlike your Azure AWS, this particular platform, we are putting it across to all OpenAI players who are developing their models. They wanted to test it across. We are putting it across from India location, our Unveiling. We are having a data center live. We are Asia's largest and world's second largest uptime tier 4 certified data center. And from that particular data center, those particular things will be running. So ultimately, your models which are going to get run will have highest of the availability. That's it. Myself and Hari is there from Utah. You can reach out to us. Unfortunately, we might not be having multiple cards. You can put across the numbers. My number is 9623 450 440.
We'll share in the community group as well.
Yeah. And the email ID is vpatil, V for victory, vpatil@yota.com, YOTTA.com. So we can put across some related demos and things when we connect one-on-one to it. That's it. My product manager and my product head is also going to be there. So after this particular event, we can connect one-on-one also. Thank you. Thanks, others, for giving the chance.
Thank you. I think this is why we are having this meetup. This does justice to the event that we are having. So thank you, sir. Okay, so next I have Mr. Nitish from Professional Block. He has a lot of experience with working on LLMs, and he's going to show you a very cool demo as to in the domain that he's working. So give it up for Nitish.
I'll just make one addition to what Adarsh said, rather clarification. I have a lot of experience in mistakes with LLM. So what all can go wrong? So I'm going to present you all. So not a lot of experience, but a lot of things which have gone wrong. From that, hopefully if you can get help, that will be a yes. So just so before the presentation comes up, right? Just from the show of hands, right? How many of you have implemented LLMs at your workplace in enterprise setting, like through API? Like firstly, how many? All of you, I'm assuming all of you have used the Chat GPT, right? So how many of you have used LLMs in enterprise setting at your workplaces through Open API or any LLMs API version, right? So lot of people, nearly 50-60%, right? Okay. How many of you have had I'm assuming if you are using through API, a lot of you are using through RAG based. RAG, are you aware of RAG? Because the talk is mostly going to be about RAG, fine tuning, prompt engineering, etc. Right? All of you are aware of RAG. What is RAG? Okay, I'll cover on that. Okay. How many of you have heard about fine tuning? Anyone? Right. Okay, good. Prompt engineering, everyone has heard about. Okay, yeah. So my talk is going to talk about RAG, how to implement it, what does RAG do, what are the mistakes in RAG, how does RAG improve upon LLM, right? So from simple Chat GPT, like how does RAG improve upon that? Then RAG, what are even if you improve from LLM to RAG, what are mistakes in RAG, right? The extent mode, you have to duplicate, right? What are failure points in RAG, and what is the latest tech stack for RAG? Like how do you improve those upon those failure points, right? And then RAG versus fine tuning, okay, and then how do you combine all of them? RAG, fine tuning, prompt engineering. Okay. So till the time it comes up, so all of you have worked upon LLM and GPT, right? So what is the maximum? What is the disadvantage on LLMs, right? Anyone? Whatever you have faced, yes sir. It does not know about your data. So mistakes about LLM, using LLM inside your organization, there are many. One of which most important is the hallucination, because second thing, it does not know about your organization data. It is not up to date, right? Okay, and if you are not hosting a LLM inside your organization, right? It does not know your organization's you can say organization's guardrails, right? You cannot upload your data, you cannot upload your data on ChatGPT, LLM, Chat PDF, etc. So that is why what most people do to implement a GPT-like solution inside your organization is take OpenAI's API, right? So I'm using OpenAI's API because that is the most of the people which are doing as of now, GPT-4. You take the API and you implement some kind of a local solution which is called RAG, which RAG stands for Retrieval Augmented Generation, right? So what does that do? So that comes some of the things which we said, that it controls on hallucination, it controls on, it grounds to your organization data, right? You can control on the language, right? And so these are the advantage of RAG, right? So then there are disadvantages as well, right? And RAG is very, very cost effective. You just need connection to OpenAI's API as your company account, and then you can go and start. And it costs a very less money compared to fine tuning. Fine tuning is something where you are actually changing the LLM's weight, and so that is another way where you can fine tuning is another way where you can come up, you can cover up those disadvantages which I mentioned, right, of ChatGPT or LLMs, right? Can you put this in presentation mode? Okay. Yeah. So these are so ChatGPT. Right. So hallucination and how to improve upon RAG. So ChatGPT, for example, cited a bogus case for a New York federal attorney. So a New York attorney was preparing for a course, right? Preparing for a defense, right? And he used ChatGPT, and ChatGPT actually in the defense, right, cited a case which never existed, right, and he presented to the court, and he got disqualified, right. And so this is a typical example of hallucination, right? Yeah. So for example, these are another examples of hallucination. Like when you ask ChatGPT, what are 3 important dates in US history, right? So it says that Declaration of Independence, start of Civil War, Pearl Harbor terrorist attack. Very good. Until you go into the details where the Declaration of Independence, the first thing, the date itself is wrong, right? So the date which comes up is July 4th, 1776, right? So now how do you improve upon that? Is that you ask LLM to find out what are the 4 most important date, and then you ground them with some kind of knowledge, right? So you add the Wikipedia onto it and ask Wikipedia to give the knowledge. See, abhi Wikipedia mein bhi galat hua, so then you can't do, right? You have to make a golden data set, something like that, right? So you add the retrieved knowledge on top of it, and then you correct this one, August 2, 1776, right? So ChatGPT is very good, LLM is very good at identifying what are 4 most important dates in US history, right? It is very good in identifying from the context, right? That from the all the retrieved knowledge around the word, like what are the four most important, events, but to get the factual, data, what is that actual date? You use RAG, right? And that you do in your organization as well. So there are two kind of hallucination. One is factual hallucination, and second is a faithful hallucination. When we go talk in depth of RAG, we will cover on that as well, right? Bharat, go to the next slide. Yeah. So these are problems with LLMs, which is hallucination. It is trained on offline and knowledge. There is a knowledge cutoff. There is no consistency, domain specificity, and there is no control and there is no guardrails on the knowledge. So RAG based architecture helps upon this, right? So so some bit of RAG plus some bit of prompt engineering, right? So yeah. So what you can do? I'll go to the next slide. Yeah. So what you can do is that this is the architecture of how you implement the RAG, right, inside your organization, right? So what do? Is that user comes to your application and asks a chatbot, which is a LLM-based chatbot, things like we set an example here, right? For example, he's implementing for a car search, right? So he asks, you can ask a question, what is your budget? 10 lakh. What car do you want? Sedan. So right. So these first two questions are being handled by the chatbot. What is the budget and what car model, car make you want? And then it connects to your database, right? Where you retrieve from that database with these two questions, right? Budget and what car make you want? You retrieve. So that is the retrieval part, right? So second, now the question you asked, you add this context, right? That within 10 lakh sedan, there are 4 cars, right? And these are their safety ratings, these are their mileage, etc., etc. And you augment this. You augment this knowledge. So this is the augment part. And third part is you send this user query plus context to the LLM again, right? And to the LLM again, and then you generate the final answer, like what is the best car for it. So he might have said, so he can build a conversation agent on top of it, like, so these are 10 cars, right, within 10 lakh sedan cars. What is your most preferred qualities? Is safety the biggest concern? Is mileage the biggest concern, etc., etc., or looks the biggest concern? So out of the 10 retrieved car, then it can tell to the users that these are 3 cars most recommended for you, right? So that is how RAG improves, some of the challenges we saw, that it will not hallucinate, it will ground to your organization knowledge, and it will answer the question with respect to your organization, right? Go next. Right. So this is a typical example, RAG. So for example, input query, who was this children's toy named after, right? So then you have, some kind of advanced thing, right? So you have, since you have an image, right? In the pipeline, you've retrieved that. So you give it to a, image detection based thing, and you identify, that what is this image of, right? So image of is a teddy bear, right? Then you go to teddy bear in Wikipedia. So actually, teddy bear is named after US President Theodore Roosevelt, right? So who was once hunting and they bought a bear near to him, his assistant, and he refused to shoot, right? And he refused to shoot because he did not like taking a animal's life just for his fun, right? And he was Theodore Roosevelt was fondly called as Teddy, right? And from next year onwards, one shop which was in that jungle started, selling a toy, right? Which was a beer toy, soft toy, right? And they call it Teddy's beer, and that is how Teddy beer was named. So yeah, so that's the history around it. So you can have RAG solve this kind of a problem, right? Yeah. So go down. So we'll give a demo of it, right? Bharat will give a demo of it, right? So in a typical organization, you might have a problem. So for example, you want to generate lot of presentations, right, based upon the documents which are there, right? So typical this problem will come for many across different roles in the organization, right? Whether you are a consultant, whether you are sales, marketing, right? So for example, here on the back end, so here he is going to plus one product. So here going to generate a PPT on the following points with relevant data, like introduction to diabetes, pathophysiology of diabetes, role of insulin in diabetes, different types of insulin. So when he searches upon that, so this, so this is the first part, retrieval part. So based upon this question, this has shown these are the documents, right, which are already present, right? So it has retrieved these are the most relevant documents, right? And this is done based upon a vector-based search because these PPTs are embedded in our database, right? So first thing you need to do to implement RAG is basically embed these documents in a vector database. For that, many algorithms are there. OpenAI has ADA02, and there are open source algorithms, and you can train your own algorithm to create the embeddings as well, right? So now he can select all of them, go down, and generate a document, right? You would have done this on GPT-4 as well, Chat GPT, but then again the same problem would have been, hallucination problem. Someone would have to check in this. So this is a use case where you want to generate from your internal organization data, right? So this is generated a PPT. If you can download the PPT and show it. We can change the format of this PPT as well, like insert your organization logo, etc. Right? Go down. Go down. Yeah. So yeah. So these are all facts coming from the internal slides presentations, and in the end they provide you reference as well. So reference of the presentation from which this has been made. So it's a typical example of RAG. So first what we have done, we have fired a query, we have retrieved which of the internal documents are most relevant, selected the ones which we want to be there in the final presentation, augmented that query with these presentation, and finally there was a prompt to generate the final PPT, which I think we can show them later, right? So generation also there is some prompt where you have to put your organization guardrail around it, like don't fill each slide with too many details. Each bullet point should be maximum 2 lines, right? There should be only 5 bullet points in each slide, etc. And try to make it within 10 slides, right? So these are prompts, right? Yeah. Yes. So don't judge it on the quality of the content. This is just for demo purpose. Well, next one, right? So this is just one example of RAG, right? And that is most of the organization which are doing it. That is how they are doing it: retrieval, augmentation, and generation, right? And where does prompt engineering? Where can you and where does the biggest problem happen? Survey from here. So now he is going to give a presentation of survey bot. What they are going to do is that, see, a lot of you have faced this situation typically in market, etc. Where do you want, when you want to conduct a survey, right? When you have launched a product, right? So basically, this is an organization which came, this is just for a demo purpose, right? We are not endorsing any of these companies' product. Right? So this is a company which came up with a COVID-19 drugs, right? So on this document, you want to generate a survey, right? So he's uploaded a document on which it is generating a survey. How to generate a survey? That is again a prompt engineering thing, what he has said is that, in that prompt, what is mentioned that, and this is a prompt which has been generated, you can scan this, QR code and fill this survey. Scan this QR code and fill this survey. And what we will show is that, and this is typically meant for field forces, right, or marketing people, right, where they have to conduct surveys, design surveys, etc. So you can upload your organization document, design a survey, right, and this survey is just a survey link is generated through a QR code. You click on this QR code, and you can fill in this responses, and after some time, the central person, right, can directly see that what are the responses coming in, and what also it can do through the generative AI is that if people are, let's say that, the document which we uploaded talked about Cipla's COVID-19 drug responses, right? And it is conducting this survey for doctors or for pharmacies, right? And where they are saying that the biggest problem is cost, price, etc. Or the biggest problem is people asking for adverse effect, or etc. etc. It can also tell you the remedial actions against them, right? So it can generate the insight. So these are the insights. Pricing is a key concern for respondents. Show the insights. Yeah, okay. So these are the insights. Collaboration with government initiated, and what is the proposed line of action, right?
So the answers or these were the questions which were formed.
Yeah. So the questions which were formed were, Bharat, if you can show the questions which were formed, right? Okay. So there was a document which talked about things, and there are questions were formed which asked people that what are the most important concerns, pricing, availability, etc. Where people filled, and after people filling it, these are the insights which are coming in. That the biggest concern is pricing, and it tells you the remedial action against it. So all in real time.
AI has formed this particular question giving that topic.
Yes. So that is what LLM is doing. You upload a document. AI is creating the survey, the questions with the choices, right? And when people are filling it, it is on real time giving you insight on what are the biggest concerns as well as what are the remedial actions against them. So all through LLM. Oh, survey. Okay, so yeah. Anything else you wanted to show in the demo? Yeah. Yeah. So this is what Ashwin was also showing, right? So for example, font run. So this is also like on the back end, right? There are 10-15 PDFs which are talking about the drug. So every time a drug is approved, there is 100 pages dossier which is meant for people who doctors, etc. Right? So to this you can ask a question: what are the recommended dosage of Paxlovid? Right? So it says that the recommended dosage for Paxlovid is 300 mg, right? Etc. Taken together, and you can also see the reference from which it is generating. So this is the this is the document from which it is generating, highlighting that portion, right? So that is again advantage of RAG. So basically it gives you, it grounds your interaction, it grounds your answer, right? So that is where it covers on the factfulness hallucination, right? So it is, that this answer is not generated. So like this is not a bogus case. This is coming from a document, right? And what else you can do is that, so you can take the summary. So you have done 10-15 questions, right? You have asked the answers for each of them. You can also generate a summary for this. So below is the summary of conversation with the bot, right? And these are the answers. So if you ask 10-15 questions, right? So you can, at the end of it, you get a PDF as a collateral, right? That this is the collateral. These are the questions you ask. These are the answers, and this is from this reference, right? So you get this as a collateral.
As you said, it is giving a reference.
Yes.
Does it validating whether the reference is proper or not?
So that is up to your organization. So this is answering questions from your organization's data, right? So if that is incorrect, then you have bigger problem to solve much before RAG, right? Yes.
We are coming to that. Yes.
Okay. Yeah, so how to implement RAG is basically first, is it ready? Yes. So first you take the document, you embed them, and you decide which algorithm which you want to embed. So you can use OpenAPI. OpenAPI is EDA02. You can use open source one, and then you find a way to, and then you store this in a vector database, right? And vector database can be anything. It can be Elastic. It can be Microsoft Azure. And when people ask the query in the LLM, you want to connect it to your vector database. And typically, there are two most popular connectors. One is LangChain, and another one is Llama Index, right? So LangChain and Llama Index allows you to connect your query. The front end query is still a GPT, right? And you connect it to vector database. So when he asks a query, right, it retrieves what are the most five most relevant documents, and then you select which one you want to take of them, and then you another one is a choice of LLM, and then you generate a response, right? And then the response, what prompt you select to generate the response, like that also depends upon the persona whom you are solving for. Because a same presentation or a same paper, a researcher can take different insights out of it, a CEO can take different insights out of it, and a salesperson can take a different insight out of it. So you can control these personas in your prompt, right? Yeah. So that is how you do it. So understood RAG, how do we implement? Everyone is kind of clear, right? Okay. Now we'll talk about sorry. So we'll talk about what are the problems that can come. So in RAG, there are only two problems which can come, right? One is the problem of search, another one is problem of inference, right? Because in the first portion, you are searching for the document, right? You are augmenting it with the user query and answering it, generating the answer, right? See, I will make it simple, right? So let's say I am GPT, right? Okay, I am GPT, LLM, OpenAI GPT, right? GPT-4. So in normal GPT conversation, what happens is that Bharat comes to me and asks me problem that, tell me history of Pune and what are important dates, right? So I have been trained on a lot of knowledge, lot of Wikipedia, Pune's history, etc., etc. I tell him from my recollection. In RAG, what is happening is that Bharat is coming, user is coming to me with 3 books. One is History of Pune, pre-independence history of Pune. Second is Maratha history of Pune. And third is, post-independence history of Pune. He's saying these are the 3 books. These are the most important chapters. Read it and answer me what are the most important date in Pune's history and why do you think so? That is what essentially is happening in RAG, right? In this, there are only basically 2 problems which can happen, right? First is Bharat is coming with wrong books to me. Instead of Pune, he is giving me books which are about Maratha history, but Maratha Empire was also in Indore, everywhere else, right? So he is coming up with Maratha history, which was non-Pune, right? So that is the mistake which can happen. He is giving me the wrong context, right? Okay, and that is problem of search, right? Okay. And second thing, within the books itself, he can point me to incorrect location. So like he's saying that yaar, ye jo book hai na, post independence history of Pune, in that he's giving me only he's pointing me to the chapters which talk about post 2020 when metro
construction happened and problems which have come post that. So that is the problem of referring to incorrect chunks. Okay. So first is problem of incorrect document, problem of incorrect chunks, because you can't read the whole book. LLM cannot read the whole book. So that is with respect to problem of search. Second is problem of inference, which is when he has given me the right set of books, but even though me as a LLM can make mistakes in inferring what is written in those books, because I have not been trained on history books. I am a mathematician. I have in never my life I have read paragraph more than 5 lines, because I am in my whole life I have solved integration differentials, although I'm not good at them as well, but I have not been trained on this problem. So that is, and third thing is that I don't know how to answer this guy. I can write in the 5 most important dates of history of Pune are, let's say one day where all flights got delayed, second day where there was a big agitation, third day where there was a big jam, because someone has written about it, right, in the book, that these days Pune's image got tarnished, etc. Right? So that is the problem of inference, right? So that how do you solve the problem of search and how do you solve the problem of inference are different techniques. Everyone clear on that? What can be the most problems with the RAG? Problem of search and problem of inference. So there are different techniques for it, and so I very simply explained 2 problems, but there are researchers who have divided this into 7 different problems. So 2 को भी ना उन्हें 7 में divide कर दिया. So problem of search में ना, problem of search is why it is happening is that because the mechanism which I use, which finds the mechanism which Bharat has used to find the most relevant books to answer those questions is wrong. उसने क्या किया है ना, भारत को ये पता है कि I provide good answers once books are provided to me, right? So Bharat had this question that history of Pune, but what Bharat is doing, being a lazy person, he has वो library में सबसे पहला जो book था उसने मेरे को उठा के दे दिया, right? Okay. So that is his retrieval technique is not correct. So you can improve that by improve retrieval techniques where you can have a semantic plus keyword based search. You can, and the chapters also you can he could have provided me correct chapters which talk about Maratha history, Maratha war, etc. Right? So for that he should have used, while doing the embedding, correct chunking strategy. On the inference part, he should have given me, he should have trained me that when you are asked to write an essay, this is the essay, how an essay looks like, right? So how do you do that? Few shot learning, where you tell me in my prompt that, when asked about history of any country with the context of books, this is how you write a good essay with example of essay of, essay on history of Mumbai, right? So that is how you improve. Go next. Yeah. So these are 7 different problems which can. So these 2 problems are divided into 7 different categories. Go next. I just quickly want to cover. So these are lessons and description. Right? So there is a recent paper which has come out named 7 failure points of RAG. Please go to that. It's only 7 pages. Next. Right. So these are advanced RAG. So this was a naive RAG, right? So you have an advanced RAG in the example which I have given, right? So what you can have is that. So before Bharat identifies the book, he has a mechanism which is called query rephrasing mechanism. So he divides history of Pune into different parts. One is history, another one is Pune. Now he goes to the history section of the library, and there he goes to geography, by geography Pune. So that ensures that he is picking the right book to provide to me. So you are adding steps in the naive RAG
which are query rephrasing to ensure that he provides you the right set of books or context. Then then he also teaches me when you give the answer now, please also generate answers from different books. Let's say 10 bullet points from each of the book which has been provided. So he has taken care to ensure that he is providing correct set of book. Now the onus lies on me, right? So what he said that from each book now, generate 10 bullet points, right? And then do some kind of re-ranking. Think about it, right? That from each book, what are the most important 10? So, and then collectively think about it, their impact, and give me the top 10, right? So this will ensure two things. One is that I don't forget a book at all. मैं तीनों book से कुछ ना कुछ पढ़ रहा हूँ. And second thing is basically I am thinking about it before providing the answer to him. So that is how you improve naive RAG to a advanced RAG. So there is a very good paper on it, which is called, I'll provide the link, or survey on RAGs, and that says naive RAG, advanced RAG, modular RAG. So essentially what you are doing, when you go to naive to advanced to modular, each portion of retrieval, augmentation and generation, you are putting more thought about it. And the way to solve it exactly like how you would solve the problem which I have said. How do you ensure he brings the correct book to me? How do you ensure that I answer the correct question to me? And these are the techniques involved. Go next. Right? Yeah. So this is dividing. Right? Go next. Right? So these are different kind of prompting technique. One is zero shot, where you directly ask the question, right? So like classify this review. I love this movie. Find the sentiment for it. This is called zero shot. One shot is give one example. I love this movie. This sentiment is positive. This is the example. Give, and then I don't like this chair. Give the sentiment for it. So this is one shot. When you add more examples, it is called few shot. Another advancement in this, right, has happened is that when you have agents, when you have a complex problem like this guy has, right, you have dynamic few shot, right? So you cannot, in his example, in his live also, like he might have problem, people asking about budget, people asking about sentiment, people asking about this. So these few short examples, right, even though how much ever you want to keep, right, you cannot have of all types, right? So what do you do is that first you understand the intent of the user. For example, मुझे LLM को ना mathematics teach करना है. So I can give him one example of addition, one example of subtraction, one example of division, right? But if I want to understand, if I want to make more advanced like board mass, etc., right? So at a very difficult division example, I want to give more examples of division. So dynamically you find out which few short examples you want to give, and that is the latest research which is done by Microsoft, and it's a paper called Med Prompting, right? You must read it, which shows that with good prompting techniques you can outperform fine-tuning. The best fine-tuning methods you can outperform with good prompting techniques, and that's why they say that prompt engineering is going to be the most required skills in era of LLM. And trust me, there is one prompt, right? Take few deep breaths, think about the answer. This has scientifically proven to increase the accuracy of answers by 5%. There is a Google paper on it, right? So this is fine tuning. In fine tuning, we change the weight of the algorithm and weight of the model itself, and that costs a lot of money, makes a lot of money for Megh's organization, right, which is trying to decrease, which is honestly telling us methods how to decrease that. So this is fine tuning, where you essentially changing the weight of the LLM itself by giving examples before, much advanced example then few short learning. Right. Go next. Right. Yeah. So this is essentially one slide which captures it all. What is prompt engineering? prompt engineering is, you give few shots, you have a chain of thought, right? Where you chain of thought is something simply such as solve this step by step, think about this step. There are many techniques such as graph of thought, tree of thought, etc. etc. Then you have a dynamic few shot. Then you have RAG, where you know how old is George Clooney, right? You refer to Wikipedia, etc. database, and then you have fine tuning, where you change the weight of the core LLM as well. So, and these are from here to here as you go, cost is increasing, and these are more advanced techniques, right? Go next. Please go next. Right? Yeah. So this is RAG book, X-ray pen. So, RAG prompting versus RAG versus fine tuning. Is external knowledge required? If and is the model adaptation required? Is the language required? So if the language adaptation required is low, but external language required is high, then you go for RAG. If both are low, you go for prompt engineering. If external knowledge required is high, if the adaptation required is high, but external knowledge required is low, you go for fine tuning. If all of them are high, right, which I'm sure all of you will say for your organization, all of them are high, you go for library, RAG plus fine tuning plus prompt engineering, right? And these are the few choice, like external fine tuning requires changes model behavior, it minimizes and it does not help in interpretability, right? And fine tuning costs more money than RAG, right? Yeah. So these are things which prompt engineering, for example, intuitive, fast prototype, easy to work with. Fine tuning, narrows model behavior, it trains the model to think in a particular direction. RAG, dynamic knowledge in the prompt, you can bring in real-time knowledge, apply data and domain knowledge, and if you want to have all of them, it's the best combination. Yeah, this is med prompting, where Microsoft has shown that with med prompting you can outperform the best of the fine-tuned model in a particular domain, right? Yeah. So med prompting is all about dynamic few shot, having a chain of thought, etc. And this shows that how the accuracy improves with all of these steps, right? So these are all the papers which I talked about. So thank you very much.
Thanks, Indic. So I hope you are well versed with LLMs and happy with the content that this has presented. Any questions on this? Yes, please. Please provide a mic.
So in your own experience, what is the best chunking strategy? Are you using any semantic chunking or?
Yeah. So basically, we started with just the 3,000 characters, count based, and then overlap, etc. But we found parent-child chunking to give us improved result. Then second thing is that breakdown at the logical places, like paragraph-based chunking, right? Or identify the sections of the document. So combination of section-based, proposition-based chunking plus parent-child, plus on top of the raw data, we added summary for, let's say, each section, right? Plus added meta tags, right? So what is this document talking about? In the example, this book is about history, this book is about Pune, this book talks about which period, right? Who is the author? Is it primary? Is it based upon primary research? So these are chunking plus adding things on top of it, meta tags, etc. Pre-processing. So your ingestion pipeline matters a lot.
Have you tried any semantic chunking?
Yeah, so we tried it, right? But it is a combination of all these factors. So you cannot tell that which one, but the best result were provided by the parent-child chunk. Because in our case, documents were very big, 700,000 pages, right? So you had to correlate the documents, right? You had to form the tree structure around the documents.
One last question. So, do you use any framework for your work, or do you build your own?
Like what?
Any framework to do the RAG? Do RAG?
RAG?
Retrieval augmented generation.
Yeah, so I mean, we use for different part, we use different component, right? For like query enrichment, query this one, we use LangChain, this one query rephrasing, right? And LangChain's, this one, and OpenAI facilities, whatever it provides.
Thank you.
It goes that you mentioned.
Yeah.
Slide was just shown for a short time.
Yeah, you can take.
We'll share the link in the group.
Yeah.
You can, if you are
So
not
there are 3-4 papers I
you
can
just
talk
scan this
about.
and join.
Yes.
Actually, I very much like the mistakes that you make. So, I mean, yes, it's not easy what you explain. Like, it takes a lot of trial and error and then reach to what you explain. RAG में एक स्टेट पे जाकर हमारा स्टोरेज पता चलता है।
Yes.
और मेमोरी के बिना नहीं चलता मेमोरी, इसलिए हमने एक्स्ट्रा लेयर लगाया था। It start getting slow after a certain time.
Yeah.
So, have you done any comparison?
Yes. So there are three ways to kind of solve it, right? So firstly is that you use so once you know the user behavior, once you know what are the 5, 10, 15, 20, right, most critical problem, then you don't do everything through GPT or LLM. You identify such as, for example, you know that if you use RAG as if you use the LLM as just as a natural language querying tool and pointer to your pipeline, right? So you cut down on that delay. So for example, you know that your tool is for a lot of people, a lot of product manager ask for a particular chart or particular behavior, right? So you take that chart making out of the OpenAI pipeline, right, or the GPT pipeline. You create for it. So basically, you use RAG, the first one, as just a agent or a router, right? And you reduce the number of dependencies on the external calls which are happening. The best one is if you can have your in-house open source. That is the second one. And third is that Microsoft is coming up with its own research on how you can reduce this one, because the limits are also on the token per minute, request per minute, all such requests are there, and that are at enterprise level, not at you can get multiple connections, etc. So you have to play around with them, but the best technique is to use the GPT interface only as an agent and identify कि अगर 50% लोग एक ही ग्राफ पूछने वाले हैं, right? So why don't I have something which just produces that graph outside of GPT? Right? So these are some of the things we said.
I think we'll take the questions in the networking session itself. Okay.
Thank you.
Thank you so much, Ritesh. Okay, so for the people who have joined us on LinkedIn, this is the end of session. We have one more session planned, and that will happen in person only. So thank you so much. Yeah. Okay. So next, I would like to